welcome back. So last lecture we were talking about the different categories of clastic rocks. So rhodaceous, arenaceous, and argillaceous, and then we were talking about that this is one of the example of the rhodaceous rock. What is the importance of this in day-to-day environment? Okay, what we look at. Okay, so conglomerate, which is comprised of clastic sediments, mainly pebble and cobble, along with the ground mass. So if cementation is good, okay, so void, that is the void between the class, then the conglomerate, okay, will be hard and compact or competent, hence act as a strong foundation. So this is an importance for C particularly, but not good rock for the groundwater source. Okay, so this is one of the important part. However, if the cementation is poor, okay, it makes the rock more porous with high porosity. So in that sense, it is good reservoir for groundwater, or it is good aquifer, but is undesirable at the site for the foundation of major sea structures. Okay, so when you come across the conglomerates, you need to know that what type of cement it has. Okay, if it is competent or good cement, okay, then you can use that as an or indicate that these are the good for the foundation. But if it is poor cementation, okay, and which breaks easily, then it is not good for the foundation. Okay, so due to heavy seepage, the conglomerate may result into failure by sliding, and one of the example for the failure of San Francisco Dam in US was because the conglomerate was poorly cemented. Now cementation in particularly, if you take, that material is usually the secondary silica, okay, and siliceous cement. If you are having calcium carbonate, we say the carbonate cement, or it is ferromagnesium cement, iron rich. So most harder, if you look at, we will find that if it is having the ferromagnesium cement. Okay, so cement itself to some extent is the source of weakness to the sedimentary rocks, as we have discussed in the previous slide. Okay, because the cementation material and the clastic sediments are usually of different composition. So you will have the clast are of different composition, and the cement will be of different composition. So that is an heterogeneity which we will have, okay, leading into the heterogeneity of their physical characteristics. Okay, so this is one important part of the cement which you can remember. Either it is siliceous, carbonate rich, or you are having the iron rich cement. Okay, so because of this, such rocks will not behave homogeneously under stress. Okay, so this is very important part when we will talk about the shear strength and all that. Okay, so since they are comprised of different material, so we will have an sort of an heterogeneity. We will have the heterogeneity of the material within that rock, clastic rock. Hence, they will behave differently under the stress. Okay, resulting into the development of cracks and fissures. So if you are having softer material, which is either the rock clast, okay, or the fragment which is of the minerals which are less harder, okay, then it will break early as compared to the ground mass. Okay, so because the conglomerates will have the heterogeneous material, the rock will not behave homogeneously under stress, resulting into the development of cracks or fissures which develops in the cementing material. Okay, so either the cementing material will crack or the rock fragments will crack. Okay, so if the cement is calcium carbonate, for example, it is undesirable because it is susceptible to dissolve in water. Okay, so calcium carbonate will dissolve in water, so it is not good. So if you find the material or the conglomerate cementation material is calcium carbonate, you should avoid. Okay, however, if the cementation process continue for longer span, okay, of time, cementation will become more complete, okay, which reduces the porosity and permeability in the rock mass and increase the competency. That is the strength of the rock will increase. So, if the process of cementation and compaction will last for longer period, then you will have better rock strength. Okay. Shape of the grains are also important. That is, if the grain size, the coarser grains are rounded or sub-rounded, then the cementing material will not have firm grip. Okay. So, if you are having breccia as compared to the conglomerates, then the breccias are better because they will have angular fragments, okay, within that. Okay. So, this is the reason why they will have the incompetentness. Okay. So, most of the coarser gravels which are the coarser grains which are rounded in shape will result into the incompetent rocks. Okay. So, this is another part in terms of the shape. Okay. So, once we have previously we have talked about the chemical composition of the matrix, okay, what we are having, or the cementing material, and then we are having the shape of the grain size. Okay. Quartz sandstone, and this is Arkose feldspar rich sandstone we are having. So, made up of sand grains dominantly of quartz and feldspars, where the quartz is highly resistive to weathering. So, cementation plays similar role in this rock as seen in conglomerate. However, siliceous cement are best and highly desirable for CE purposes, also the ferromagnesium sandstone. Okay. Use of sandstone in historical structures. Okay. So, if you look around and just try to see that different monuments, historical structures in India itself, you will find that most of the historical structures in Delhi and around are made up of sandstone. Okay. And those are again the ferruginous sandstone. Okay. So, we are having mostly this type of material. So, this is in Red Fort, which is in New Delhi. A red sandstone was been brought from the quarries of Dholpur in Rajasthan and Fatehpur Sikri. So, this is the example of the sandstone and the structure which was been constructed from the sandstone. This is inside that region. Okay, we are having again, you can see beautiful carving is in ferruginous sandstone. Again, Qutub Minar. Of course, this part is having marble, but rest of the stories are having all sandstone. Okay. Then we are having the famous area in Fatehpur Sikri, and along with the Buland Darwaza, this again is made up of sandstone here. Okay. Then this is in the Agra Fort. Now, coming to the another finer size sedimentary rocks. So, we have seen conglomerate, we have talked about sandstone, we have talked about the now we will talk about the finer one, which are shales. Okay. And please remember that what is the importance of the cementing material, what is the importance of the shape of the clastic grains, okay, or the clast. Okay. Now, shales are mostly fine grains. So, they mainly comprise of silt or clay. They are most abundant sedimentary rocks, account for about 80% of them. Okay. Often contain fossils, mostly hydrous aluminum silicate in composition, sourced from weathered feldspars. Okay. So, deposition takes place under low fluvial regime or low fluvial conditions, or under weak water currents, offshore or in lagoonal environment also mostly seen. Okay. Shales are made up of fine, well sorted silt and clay sediments, where these clay sediments have tendency to retain water. Okay. So, in the beginning, when we were talking about the minerals, okay, the clay minerals have sheet structures. Okay, and sheet structures are having capability of holding water. Okay. So, they have the capability of retaining water, which can result into the weakening of this type of rocks, that is particularly shale. Okay. So, if you are coming across shale, this again it is not very good to put any civil structure on that. Okay, because it can hold water and result into the slippage along the plains. Okay. So, sea importance if you take in terms of when shales are saturated with water, under pressure they are likely to produce slippery foundation for any structure. Okay. Therefore, not suitable for putting any civil structures on that. Okay. Example, Lafayette dams of US constructed on the argillaceous rock. Okay. It sunk by almost 20 feet. Okay. So, this was the mistake which was been done in US, also in India, Srisailam Dam in Andhra Pradesh. So, one of the 12th largest hydroelectric project in India faced similar problem. However, precautions were taken by grouting and stopping the seepage, but had a problem because of it had a foundation which was made up of shales. Okay. Then because of that is the shale, because of its impermeable and porous nature, it acts as a cap rock for the occurrence of oil and gas. So, in a way it is good for the fuel minerals, but it is not good for the foundations. Okay. So, evaporitic rocks, if you look at, then these rocks are formed within depositional basins from chemical substances dissolved in seawater or lake water. Okay. So, one is gypsum, again they are evaporites, so mostly seen in the arid region or semi-arid regions. Okay. And then we are having the halite. Okay. Economic importance of the evaporites: salt, of course, other than daily use of the salt cooking, we use for cooking and other than that we are having for the production of paper, then we are having in soap, detergent, antiseptics, okay, as chemical for dyeing industries. So, gypsum particularly is used for plaster and is manufacturing construction material. Okay. So, we are having the economic importance for this minerals. Okay. This rocks, okay, evaporitic rocks, mainly the salt and gypsum. Then we are having the carbonate rocks. So, limestone, it is again a non-clastic rock formed either chemically or due to precipitation, okay, of calcite or from the organic material, or we can say the organisms, usually the shells. Okay. So, limestone formed by chemical precipitations are usually fine grains, whereas which are formed which comprises the organisms are comparatively coarser grains. Okay. So, whereas in the case of organic limestone, the grain size varies depending upon the type of organisms responsible for the formation. So, either the shells are larger size or the smaller size, depending on that it will be the grain size will be seen. Okay. But most of the because of the precipitation, if you see the limestone, they are fine grains. Okay. They are also termed as fossiliferous limestones. They are medium to coarse grain in nature, and as it formed out of the cementation of the shells. Mostly the shells are responsible. These are this example of the fine grain limestone, and here you are having coarser grain limestone. Okay, fossiliferous limestone. So, you can see the shells here, the size of the shells here. Okay. And these are all medium size shells, but most of the here you are having larger shells, and then you are having a ground mass, whereas here mostly you see is the shelly material or broken shells. Okay. Then we have chalk, which is again in fine grain rock, sedimentary rock. It is made up of carbonate shells and mostly the very fine or small size organisms, we can say, which are termed as foraminifers. Okay. A very fine grain. So, used as a building stone and in manufacturing of lime and cement, massive, they are massive and compact in nature. Okay. So, they are competent to support the sea structures. However, if it occurs in huge thickness, then it is not advisable because they typically have the caving characteristics. Okay. subsolution activity will result into the caving effect. Hence, in most of the places, if you are having very thick deposit, they are not advisable for the putting any civil structure on that, okay, because it will result into the subsidence of the surface of the because of the caving from below. Now, coming to the structures, okay. So, we have looked at the composition, then we were talking about the grain size, we were talking about the shape. Now, we will talk about the sedimentary structures mainly, okay. Now, looking at the sedimentary structures also, one can also talk about that the depositional environment, also the energy conditions and all that, okay. Now, before getting into the these sedimentary structures, we will just look at that we have the either structureless, okay, or they are having poor beddings or they are well bedded, okay. So, there is no structure, so very calm environment, so deposition has taken place. So, bedding plays is most important feature of the sedimentary rocks, okay, and the beds which are having usually size greater than 1 centimeters are termed as beds, okay, for the layers which are having the size greater than, so thickness is greater than 1 centimeter, they are termed as beds, and the layers which are having the size or the thickness less than 1 centimeter are termed as lamellae. So, orientation of the bedding helps in knowing the paleo currents also. So, these are horizontally stratified, so they are deposited in a very calm environment, but if you and mostly this type of structures are associated with the lacustrine or the lake environment, where you are having a basin and then very calm deposition is taking place. But if you are having a floor deposit, then this orientation or the angularity of this will change, that is the attitude of the beds will change, will have different angle, okay. So, cross bedding refers to beds, okay, indicating the deposition under variable flow regime, okay, and it helps in identifying the depositional direction, in which direction they were deposited. So, for example, we are having, these are the cross stratification here, okay. So, we are having this inclination here. So, we can say that deposition was in the deposition took place in this direction, okay. So, the flow was in this direction. Similarly, here we are having fine grain lithophases, and then we are having the medium to coarse grain lithophases. So, this also helps in identifying or understanding. So, this is the contact here, which is a gradational contact. We cannot say that as a very sharp one, but we can. So, we have in contact here, we can say. So, graded bedding, if we take, what we see is that we will have the coarser deposits at the bottom, and then we have the finer deposit at the top, okay, which is what we call the fining upward sequence, okay. And this again indicates the deposition, either it was fast, or maybe we can say it was within high energy conditions, and slowly it reduced or lost its turbulence, okay. So, when it started with the deposition was turbulence and then slows down, okay. So, the grain size varies from bottom to top, okay. So, at this stage, the heaviest or the largest particles will settle down fast, followed by the lighter ones and the smaller ones on the surface, okay. So, we are having the graded sequence here, okay. So, if you look at this part, then we have different cycles here, okay. So, one is coarser, then become finer. So, this is one we have, and then coarser and finer we are having another cycle, and then we are having this one is third here, okay. So, we have at least 3 sequence of deposition in this one, okay. So, flow conditions started with the turbulent one, slowed down, and then turbulent one slowed down. So, we are having different cycles here, which also you can identify if you understand the graded sequence in the nature, okay. So, this is an example of the graded sequence. And as I was talking about that, the horizontal laminations, okay, will help you in identifying again that what was the environment in which they were been deposited. So this which is we say that rhythmic layers. Okay, so they are having very fine layers which have been seen, and they are indicative of deposition under the lake environment. Okay, so when you understand this deposits or try to date, you can also try to understand that the depositional sequence in this region. So this indicates a very calm environment under which they got deposited. They are termed as wharfs. Then these are the illustrations which gives you an idea about the surface manifestation as well as the structures of different in which were formed in different sedimentary environments. Okay, which are like, for example, you are having horizontal stratas. Okay, and then you are having graded beddings. We have already discussed. We have cross beddings, which also helps you in identifying the flow directions. So the flow. Okay, so this will indicate again the flow direction here. Then we are having the cross beddings, okay, which are having bimodal directions. So this also indicates that if you take this one, okay, fine, they are inclined, they are showing inclination here. Okay, so they got deposited here, the flow direction again. So they are having different directions of the flow, and mostly seen in the areas where you are having the bidirectional mode of deposition. Okay, so in the coastal region again you will see this type of things, and also in the where you are having the formation of sand dunes and all that. Okay, and the oscillations, again this type of ripple marks are formed where the oscillation of water is back and forth, mainly in tidal regions. Okay, so we will find this type of deposits. Similarly, again we are having more which you can go through, which we have mud cracks, okay, on the surface. Then we are having fruit marks. Then we are having the roots, or maybe we are having the animal burrows and all that, and different type of burrows are there. And then we are having footprints also, which usually get preserved on the surface, are also been help to identify the different type of environments and all that. Okay, or the floras and faunas from that region. Okay, so cross stratification. This is the direction of the flow. If you are having the cross bedding here, and the direction of the flow, you can talk about that, how they will be deposited. Okay, so again you can have the flow directions. These are the indications of the inclination of the beds, but the deposition, the direction will be in the opposite one. Okay, and then you are having sand dunes. So again you can try to identify or understand the different depositional environment. Okay, how they were been deposited. So you can have large scale cross stratification and dunes also, which can help you in understanding that how this dune was built up. Okay, cross stratification, this we termed as in cross stratification. We are having cross cutting relationship between the different beds here. Okay, then we are having ripple marks. Okay, which again, as I was talking about, that they will indicate the depositional environment at different locations. So on the surface you will be able to see this type of features, which are because of the oscillation of the water in the region. Okay, so in sections you will be able to see this type of deposits, and in fossilized rocks you may come across the features which you see in the present day tidal environments. Okay, which can tell you easily that this was the region which had an environment which was very much like a tidal environment which we see today. Then biogenic structures or the footprints can also help you in identifying the different what we can say floras and faunas in the region. Okay. So this is an example of the footprints. Okay, so this will talk about the will tell about the faunas, but floras you may have the leaf prints, or maybe you can have the fossilized wood or something like that, which can help you in identifying that. Okay. So mud cracks, again in the tidal environments you can find, or the regions where you are having very dry spills. So you can also look at the different type of structures. So this is in present day, and this is an older one, which are found in the sedimentary rocks. Okay. So these are all related to the sedimentary structures. Okay. I'll stop here, and we can start with the next lecture talking about the metamorphic rocks. Okay. Thank you so much.